Boilers contain hundreds or even thousands of tubes. In most modern boilers, steam is generated inside these tubes. The main function of a boiler tube is to transfer heat that is produced by burning fuel to water or steam. Heat from burning fuel passes in through the tube wall where it is picked up by the water or steam. This raises the temperature and pressure inside the tube. In order for a boiler to function properly, the tubes must be strong enough to contain the pressure that they are exposed to without breaking open and leaking. The boiler that doesn't leak hasn't been built. And when we talk about boiler leaks, we're almost always talking about tube failures. Since tube failures are a major cause of boiler shutdown, it's important that you know about them and how they're repaired. The tubes that are used in a boiler look like the one you see here. Some are bigger and some are smaller. It looks very much like a pipe, but it isn't exactly the same as a pipe. Because of the boiler design requirements, tubes are almost always used in boilers. It's important for you to be able to tell the difference between tubes and pipes. For one thing, a pipe will often have a seam that runs along its length. The seam is formed when the pipe is manufactured. Tubes, on the other hand, are manufactured so they do not have seams. Boiler tubes also usually have thicker walls than ordinary pipe. Another difference between pipes and tubes is the way their size is measured. Most pipe sizes are based on the inside diameter of the pipe. Tube sizes, on the other hand, are based on the outside diameter of the tube. So, when the same size of pipe and tube are put side by side, it's obvious that there's quite a difference. Selecting a piece of tube to be used in a repair is something that is often necessary when making a tube repair. Something else that is always necessary is welding. Welding is a method of joining metals by using intense heat to cause them to melt and fuse. Now, we won't try to cover everything that is involved in making welds. Welding is a complex subject, and it would take a lot of time to cover it thoroughly. Our purpose here is to cover tube repair techniques. Generally, we will cover how these repairs are made so that you'll understand what has to be done to repair a boiler tube. But first, let's discuss why tubes fail. There are 5 basic causes of boiler tube failure: overheating, corrosion, erosion, mechanical stress, and material defects. Each of these weaken the tubes and reduce their ability to contain pressure. Overheating is the most common cause of boiler tube failure. Overheating can result from deposits from boiler water, inadequate flow of water or steam through the tubes, improper flow of hot gases through the boiler, refractory failure, and improper operation. Boiler tubes are constantly exposed to intense heat. In fact, the temperature is so high that it could melt the tubes. The reason they don't melt is that the water and steam flowing through them keep them cool. Although that water and steam are very hot, they are still cool enough to keep the tubes from melting. Overheating and possibly tube failure result when water or steam are prevented from cooling a tube. Now, one way this can happen is when deposits from boiler water coat the inside of a tube. Scale is an example of a deposit from boiler water. When scale gets too thick inside the tube, it insulates the tube from the cooling flow of water or steam. The metal will overheat, weaken, and then rupture. Blockage in a tube can cause inadequate flow of water or steam through the tube. If the flow is so restricted that the tube can't be kept cool, tube failure from overheating will eventually result. Overheating from improper flow of hot gases happens when the tubes are exposed to more heat than the normal cooling flow can handle. One example of improper flow of hot gases is flame impingement. Flame impingement is direct contact of furnace flame with the tubes. When flame comes in contact with the tubes, it can raise their temperature so high that they fail. Refractory failure is another cause of overheating. Refractory is a heat-resistant material that is sometimes applied to tubes to protect them from direct exposure to hot gases. When refractory fails, tubes that are usually protected are exposed to a lot of heat. Then, the normal cooling flow is not enough to prevent overheating from taking place. Improper operation, like overfiring the boiler, also causes overheating. Overfiring happens when too much fuel is fed to the boiler. This raises the boiler's temperature. If the tube metal gets too hot, the tubes will fail. Another basic cause of tube failure is corrosion. Corrosion is deterioration of metal through chemical action. It can appear on either the inside or the outside of the tubes. At either place, corrosion causes failures because it thins out the tube walls, reducing their strength. There are many ways that corrosion can happen inside a boiler tube. One way is through improper water treatment. If the wrong chemicals are added to boiler water, or if incorrect amounts are used, the tubes will corrode. Corrosion can also be produced by oxygen in the boiler. The high temperatures and pressures in the boiler cause oxygen to rapidly attack the metal. Another way corrosion can happen is by leaving a boiler open and wet during shutdown. This will lead to rust, which is a form of corrosion. Corrosion can also be a problem on the outside of the tube. Here, corrosion is the result of moisture combining with the sulfur found in ash or soot. This produces acid, which attacks the tube metal and corrodes it. Corrosive slag is still another cause of corrosion on the outside of the tube. Corrosive slag is formed by contaminants in the fuel. The next basic cause of tube failure is erosion. Erosion is the gradual wearing away of tube metal. This weakens the tube. It can occur on either the inside or the outside of the tube. Erosion on the inside is produced by the flow of water or steam, on the outside by the flow of gas and ash. Erosion from gas and ash can be particularly severe in coal-fired boilers because they produce large amounts of ash, which is very abrasive. Erosion can also result from steam leaks. This happens when steam from a leak in one tube is directed against another tube. The steam can erode the metal of the tube and cause a failure. Mechanical stress is another basic cause of tube failure. Mechanical stress is the result of pressure, thermal expansion, the weight of the tubes, and vibration. Tubes are built to withstand a certain amount of mechanical stress, but excessive stress leads to failures. For example, boiler tubes are designed to contain pressure. Sometimes extreme pressure can burst the tubes, but that isn't common. What's more common is that something will weaken a tube and normal pressure will rupture it. Thermal expansion is another cause of mechanical stress. Expansion takes place whenever the boiler is fired. The metal tubes expand when they're heated and contract each time they're cooled. If this expansion and contraction can't take place freely, mechanical stress is created. Mechanical stress is also created by weight. Boiler tubes must support their own weight plus the weight of their contents. In boilers that hold a lot of water, this weight puts a heavy mechanical stress on the tubes. The tubes are designed to withstand this stress, but if they're weakened by overheating, corrosion, or erosion, they may not be able to handle it. Vibration sets up another kind of mechanical stress. The flow of water or steam through a tube and the flow of hot gases around a tube can sometimes cause vibration. We've exaggerated the vibration to make it easier to see. As a tube vibrates, it bends back and forth over and over again. This repeated bending can cause the tube metal to crack. This is called metal fatigue. Another cause of tube failure is a material defect. It's a weak spot in a tube metal that was there when the tube was manufactured. A tube that has a material defect, like a thin spot in the wall, may fail as soon as it's put into service. These defects may not be noticed. Tubes should be inspected for material defects before they are installed. A defective tube is much more likely to fail during normal boiler operation than a non-defective tube. We've now gone over 5 basic causes of tube failure: overheating, corrosion, erosion, mechanical stress, and material defects. We've pointed out the different reasons for each and the ways they can cause failures in your boiler's tubes. Now, take a few minutes to make sure that all the material we've covered so far is clear to you. Now that we've covered the basic causes of tube failure, let's go over some of the types of tube failures and deformities. Deformities are irregularities in the tube metal that can lead to tube failure. First, let's examine different kinds of failures that cause leaks. The first type is a rupture. There are three kinds of ruptures: thin-lipped, thick-lipped, and double-ended. Thin-lipped ruptures are usually caused by sudden and severe overheating. They look something like a burst bubble. The open lips are uniformly tapered to sharp, knife-like edges. There is no evidence of cracking or irregular tearing of the metal in a thin-lipped rupture. Now, thick-lipped ruptures are caused by milder but more prolonged overheating. This kind of overheating is often caused by deposits on the inside of the tube. Thick-lipped ruptures resemble thin-lipped ruptures, except that their edges are thicker and more ragged, as you can see here. This kind of rupture is common to superheater tubes. Double-end ruptures are also caused by overheating. Here, the tube separates completely at the point of failure, leaving two free ends. Three more failures you may run across are fatigue cracks, tearing of tube metal at weld patches, and the tearing of tube metal at support clip attachments. Fatigue cracks are caused by mechanical stress. They appear as clean, bright breaks through the tube. Tearing of the tube metal at weld patches is also caused by mechanical stress. This occurs when the weld patch and the tube expand or contract at different rates. Contraction can stress the metal so severely that it tears open. This kind of failure can mean that the wrong kind of material was used for welding the patch. Tearing of tube metal at support clip attachments is also caused by expansion and contraction. Support clips are brackets that are welded to some tubes to help hold them in place. If tubes that are held together by support clips expand or contract unevenly, a tube may be torn open where the clip is welded to the tube. Thermal cracks, sometimes called creep cracks, are another type of tube failure. Prolonged mild overheating or repeated short-time overheating creates thermal cracks. The cracked wall will have a normal thickness, but the crack itself will have a dark, crystalline appearance. Another type of failure, pinhole leaks, can result from overheating, corrosion, erosion, mechanical stress, or mechanical defects. It looks like a small hole in the tube surface, but it goes through the entire tube wall. Often, a pinhole leak is the way a larger failure starts, so it can't be ignored just because it's small. Pinhole leaks allow steam or water to leave the tube in a concentrated stream. If this stream is directed against another tube, it will erode it, eventually producing a failure. This is called steam gouging. Steam gouging looks as though the metal has been blasted away and the resulting cavity polished. The cavity is extremely smooth and has an irregular shape. Now that we've talked about tube failures, let's take a look at some tube deformities. Deformities, as we said earlier, are irregularities in the tube metal that can lead to failure. The first two types of deformities we'll look at are tube enlargement and heat blisters. Both of these are caused by overheating. Tube enlargement is common in superheater tubes. It appears as a uniform enlargement of a portion of the tube. The overheating that causes it is milder than the temperatures responsible for ruptures and cracking. But if an enlarged tube stays in service, it will eventually rupture or crack. Heat blisters, also caused by overheating, only affect one side of the tube. Heat blisters always indicate the presence of waterside deposits. Waterside deposits insulate the tube from cooling flow and cause the tube to become overheated. The blisters are formed when a portion of the tube metal becomes so hot that it softens. We're going to slow this process down so you can see what happens. The pressure inside the tube causes it to bulge outward. As the tube bulges, the deposits inside break up, allowing boiler water to cool the hot metal before the tube ruptures. The heat blister then appears as an egg-shaped lump or bulge in the tube. The last two types of irregularities we'll discuss are tube thinning and tube wall lamination. Tube thinning is caused by corrosion or erosion. It shows up as a general decrease in the wall thickness of the tube. As you can see here, the wall of the tube where my finger is on the top is much thinner than the tube wall at the bottom. Tube wall lamination is the most common example of material defects found in boiler tubes. A cross-section of a laminated tube looks something like this. The lamination, or layering, occurs during fabrication of the tube. It will appear as cracks or breaks that go partway through the tube. We've now covered 9 common types of boiler tube failure. Thin-lipped ruptures, thick-lipped ruptures, double-ended ruptures, fatigue cracks, tearing of tube metal at support clips, tearing of tube metal at weld patches, thermal cracks, pinhole leaks, and steam gouging. We've also gone over 4 tube deformities: enlargement, heat blisters, thinning, and lamination. You should be familiar with the causes of failures and deformities and what they look like. Now let's take a quick look at how they're repaired. The best and most sure way to repair failures and deformities is to replace the damaged section of tube. Although this is the best way, it isn't always possible because it's time-consuming. There are several other methods that are used when there isn't enough time to replace a section of tube. These are cladding, closing a rupture, and window repair. Cladding is sometimes used to repair tube thinning. It's a technique used to thicken and strengthen a tube by applying weld metal to its surface. If there's a rupture in a tube, it can sometimes be repaired by forcing it closed and welding it. This type of repair is also clad to increase its strength. If a rupture cannot be closed, it's sometimes possible to perform a window repair. In this repair, the damaged area is cut out and replaced with a new piece. Selection of the type of repair will depend on the type of failure and the amount of time available to fix it. We'll see exactly how these repairs are performed in a few minutes, but right now take some time to go over the material on tube failures and deformities in your text. Knowing why a tube fails and what to do about it is important because it is essential that failures be repaired. What we're going to do now is take a look at some ways of fixing boiler tube failures. All the repairs we'll be dealing with require welding. In a boiler, this work must be done by a certified welder. However, as a maintenance person, you may have to assist a certified welder, and you'll need to know how the repair is done. Remember to review welding safety precautions before work is started. There are special hazards involved with welding. These hazards include intense ultraviolet light from the electric arc, fumes from the welding itself, and danger from hot sparks and molten metal. Make sure that you keep safety in mind at all times. There are several precautions that must be taken to protect against hazards caused by welding. First, the welder and his helper must be protected from the electric arc's intense light by welding shields. These shields have special glass lenses that filter this light to keep it from damaging the eyes. Second, the area where the welding is done must be well ventilated because of the harmful fumes produced by welding. In a confined area, it may be necessary to set up a portable fan to get adequate ventilation. Third, the welder must wear gloves and heavy clothing to protect him from sparks and molten metal. Some companies have even more safety requirements. Check for these in your safety manual. The manual will also list precautions that must be taken when working inside a boiler. The actual repairs you'll be involved with will be done inside a boiler, but in order to clearly demonstrate the procedures, we'll be working on individual boiler tubes in the shop. Each of the repair procedures we'll talk about will be demonstrated this way. The first method of tube repair is the replacement of a section of tube. Here, the length of tube containing a failure is cut out completely and replaced by a new section of tube. Replacement of an entire tube section can be done to repair any kind of tube failure. Replaced tubes are as good as new ones. You can replace every tube in the boiler or as much of one tube as necessary. The problems with replacement of a tube section are that it is time-consuming and expensive. Still, it is sometimes the only procedure that can be used because the damage is too severe to be repaired by any other method. When getting ready to assist in a repair, be sure you're thoroughly familiar with the procedure. If your plant has a written procedure, read it over carefully and be sure you understand it. If there are no written procedures, talk the process over with an experienced welder. Also, make sure that you know the materials, equipment, and working methods that apply specifically to your boiler. The type of metal that the tube to be repaired is made of and the type of weld rod used for the job are both important considerations. There are a lot of different kinds of weld rod available, and there are a variety of metals used in boiler tubes. The type of tube metal and the type of weld rod must be compatible. If the wrong kind of rod is used, the weld made with it is very likely to fail. For this reason, the foreman or an experienced welder usually chooses the type of welding rod. In addition to the welding rod, you'll need a replacement tube. The new tube must be the same type of tube as the one that failed. It has to be made of the same type of metal and its dimensions have to be identical. Your manufacturer's manual will tell you what metal the original boiler tubes are made of. Using the right replacement tube is very important. Before starting the job, get all of the equipment you'll need to do the work. First of all, you'll need a welding machine. If there's a written procedure, it may call for a particular type of welding machine. The tools that are needed include a rod holder, which is also called a stinger, a grounding cable, a slag hammer, a wire brush, a saw to cut the tubes, and a grinder. Before they're used, check the tools to ensure they're in good condition. For example, make sure that the welding cables are not frayed or broken. Once preparations and precautions are finished, the procedure begins by cutting out the damaged section of tube. Here, we'll do the cutting with a saw. Now, this type of saw is attached to the tube that will be cut. This is done by attaching a clamp to the tube and then attaching the saw to the clamp. Cutting is done with a saw rather than a cutting torch to avoid getting slag inside the tube. 2 cuts must be made to the damaged tube section, one above the failure and one below. When the damaged section has been removed, the remaining tube ends are prepared for welding. Both free ends must be beveled. Beveling, or scarfing as it's sometimes called, is the process of tapering the end of a tube. This is done with a grinder. You may need ear protection when this is done, particularly if the grinder is driven with an air motor. Next, the distance between the free ends of the tube is carefully measured. It's important to get an accurate measurement so the replacement section can be cut to fit in the available space. Space is left for the beveling that is done to the free ends of the tube and to the replacement section. The replacement piece may be cut on a saw in the shop. The ends of the replacement section must also be beveled. This can be done in the shop before the replacement section is taken to the boiler. Once the ends are prepared, the replacement section must be tack welded in place. To hold the replacement piece while it is being tack welded, a brace, like the one you see here, is sometimes used. Tack welds are small spot welds that are made to hold the replacement section in place while the final welds are being made. The final welds must be made by a certified welder. As a weld is made, an impurity called slag is produced. Slag must be removed, and this is done by chipping it off with a slag hammer. To remove any remaining slag, a wire brush is used. Once the welds are finished, the repair is complete. A repair like this is usually tested by pressurizing the boiler. This is called a hydrostatic test, and it's done to make sure the welds don't leak. That completes the procedure. Let's sum up the key points. The material and equipment you need for replacing a section of tube are weld rod, a replacement tube, a welding machine, a rod holder, a grounding cable, a slag hammer, a wire brush, a saw, and a grinder. There are 5 steps for the repair. Cut out the damaged tube section. Bevel the remaining ends. Cut the replacement tube to size and bevel the ends. Tack weld the replacement section in place. And weld the replacement section to the original tube. Take some time now and clear up any problems or questions you may have. Cladding is a welding technique used to apply metal to the surface of a tube. When a clad patch is applied properly, it thickens and reinforces the tube wall. Clad patches are preventive measures used to avoid boiler tube failure. Cladding is often used to repair localized tube thinning caused by corrosion and erosion. The thin area is covered with weld metal to strengthen it. This cladding helps hold the tube together and makes it less likely to fail. The additional metal added to the tube makes the damaged area more resistant to corrosion and erosion. Cladding may be used as a repair method whenever a tube requires reinforcement. Once it's been determined that a tube needs cladding, the first thing to do is to read through the cladding procedure. If a written procedure doesn't exist, talk the process over with an experienced welder. Now, the next thing to do is to get the materials and tools together. The only material that is needed for a clad repair is weld rod. It's very important that the right weld rod is used. The rod metal must be compatible with the tube metal. If it isn't, the clad patch could eventually damage the tube. The tools you'll need for a clad repair are a rod holder, a grounding cable, a slag hammer, a wire brush, and a grinder. You'll see how these are used to make the repair in a few minutes. Before you start, make sure you've taken the necessary precautions to protect yourself from the intense light caused by welding, from welding fumes, and from sparks and molten metal. Once the equipment and tools are ready and all the safety precautions have been followed, the repair can begin. Clean the area to be clad so it's free of rust and other deposits. Hard deposits or irregularities on the tube must be removed by grinding. The tube should be ground down until the surface is bright. Next, weld metal is applied to the damaged area. Each pass with the weld rod leaves a strip of metal called a bead. The bead is applied lengthwise along the tube. Whenever the bead is stopped, slag is removed by chipping and wire brushing the surface. The procedure is continued until the entire area is covered. The beads should be even so that they have the same thickness throughout. There should be no spaces between the beads, and the thin part of the tube should be covered completely. As the patch is being applied, it is necessary to stop periodically to change the weld rod or to inspect the weld. Each time welding is stopped for any reason, slag must be removed from the weld with a slag hammer and wire brush before continuing. Also, the weld is inspected to see that the surface of the tube is covered properly and that the arc hasn't burned a hole through the tube. That ends our demonstration of the clad patch procedure. Remember, the tools and equipment you'll need to do a clad repair are well rod and a rod holder, a grounding cable, a slag hammer, a wire brush, and a grinder. The steps in the repair are clean the area to be clad and apply the weld metal. Again, cladding is used to thicken and reinforce the tube wall. It's used to repair tube thinning caused by corrosion and erosion. If tubes are thinned only from erosion on the outside of the tubes, a tube shield is sometimes used instead of a clad patch. A tube shield is a metal plate, usually made of stainless steel, that is bent to fit over a tube. It is put on the side that is subject to thinning and then tack welded or clamped in place. The tube shield is effective in preventing continuing thinning from erosion on the outside of the tube. A tube shield is easy to install and requires little, if any, welding. However, it's not effective against thinning caused by corrosion, and it does not reinforce the tube like cladding does. Let's stop here for a few minutes so you can make sure that all the information is clear to you. All of the repair procedures we've looked at so far used some kind of welding. Now we'll show you how welding can be used to repair thick-lipped ruptures. The procedures you're about to see can also be used to fix cracked or torn tubes. To fix a thick-lipped rupture, the edges of the break must be closed and rejoined. A repair like this will usually be made only on an emergency basis. In such a case, the repair would only be temporary until time is available to replace the failed section of tube. Before the job is started, get familiar with the procedure. Again, your plant may have a written list of instructions. If not, discuss the operation with an experienced welder. The equipment and material that will be used is the same as the gear we saw earlier, except that now a gas torch and a hammer will also be used. The torch is used to heat the tube metal. This makes the rupture easier to close. There are several ways to close a rupture, and we'll demonstrate one method shortly. First, check all equipment with safety in mind. Make sure it's in good condition. Check the safety manual to see if any other equipment or precautions are required. There are special safety procedures to follow anytime work is done inside a boiler. The safety manual should be followed closely. When all the preparations have been taken care of, it's time to repair the rupture. We're going to demonstrate the procedure in the shop, although normally the work would be done inside the boiler. The repair steps are about the same no matter where the job is done. First, use the gas torch to heat the metal around the opening. Adjust the torch until it has a broad flame. Move the flame over the tube to heat it evenly. The tube should be heated until it's cherry red. If you hold the torch too close to the tube, it will get too hot. The tube should be hot enough to bend, not hot enough to melt. Once the tube has been evenly heated, close the rupture by pounding the tube with a hammer. This forces the edges of the rupture back together. Eye protection must be worn when doing this because fragments of metal might fly off the tube. If the tube cools off before the edges of the rupture are close enough together, the heating and pounding process will have to be repeated. The edges should be forced as close together as possible, but they don't have to touch. Take care not to pound so hard that you dent the tube. That can restrict the flow inside. Once the edges are as close as possible, they're prepared for welding by grinding them smooth. A V is made in the opening at a 35 to 40 degree angle. Whenever you're near a grinding operation, wear face protection. Ear protection may also be required. The full length of the opening should be ground, paying particular attention to the ends. The tapered ends should be ground so that they are rounded. This is important because the tube can rupture in the exact same place unless the ends are completely ground. Next, the surrounding tube surface is ground down to prepare it for cladding. This kind of repair is usually clad to reinforce it. Once the rupture has been closed and prepared, the edges of the rupture can be welded together. Remember, when a boiler is being repaired, the welding can only be done by a certified welder. The number of passes needed to fill the opening will depend on the thickness of the tube. The cladding is applied in the same way we showed you earlier and should extend well above and below the repaired area. After the repair is completely finished, the boiler will usually be hydrostatically tested. If a hydrostatic test is done, inspect the repair during the hydro to make sure it doesn't leak. To sum up, there are 4 steps in this weld repair procedure: heating and closing the rupture, grinding the edges and the surrounding tube surface, welding the edges together, and cladding the repaired area. To do this, the following material and equipment is needed: welding rods, a welding machine, a rod holder and grounding cable, a grinder, a slag hammer and wire brush, a gas torch, a hammer, and protective equipment, including a welding shield, welding gloves, and face protection. Your safety manual may list additional requirements. Those are the major points. Now take some time to go over any questions or problems you may have. Let's continue our discussion of boiler tube repair by going over the window repair method. In this procedure, the failed area is cut out of the tube and replaced with a new piece of the same shape. As you can see, the area that is cut out looks something like a window. Window repairs are more difficult and time-consuming than closing a rupture. They're used when the edges of a thick-lipped rupture cannot be forced together. Window repairs are also used if pieces of the tube are blown away. Generally, window repairs are most useful for fixing failures in large tubes. As with other repairs, the first step is to familiarize yourself with the procedure. Read over the written instructions or talk to an experienced welder. Then, get your materials and equipment together. You'll need some welding rods and a length of tube from which to cut a replacement piece. The replacement tube must be of the same size and material as the original tube. Check your boiler manufacturer manual to find out the makeup and dimensions of the original tube. For equipment, you'll need a welding machine with a rod holder and grounding cable and the usual welding tools, a slag hammer, and a wire brush. You'll also need a grinder and a cutting wheel. This is used to cut out the damaged piece of tube and may also be used to cut out the replacement piece. Now, the same protective equipment mentioned before is necessary when making window repairs. A welding shield and welding gloves are needed, and so is a full face shield when the grinder is being used. Your safety manual may list other precautions, so be sure to check it before you start working. Once all preparations and safety precautions are taken care of, mark off an area of the tube that fully encloses the failure. This area will be cut out of the tube. Next, tack weld a rod to the section that will be cut out. This will act as a handle to prevent the section from falling into the tube when it is cut out. Then, the grinder and cutting wheel are used to cut along the marks until the section is free. Carefully measure the size of the window left in the tube. Mark off the same sized area on the replacement tube. The piece that was removed can be used as a template to mark the piece to be cut. Using the grinder and cutting wheel, cut the marked area out of the replacement tube. The piece that is cut out will be welded into the tube being repaired. Before welding, the edges of the replacement piece and the edges of the tube opening must be beveled and ground smooth. Once this has been done, the replacement piece is ready to be tack welded in place. To do this, a welding rod is first tack welded to the center of the patch. This acts as a handle for holding the patch while it is being tacked. The welder then tack welds the patch in place. Once the replacement patch is tacked, the final welds can be made. This welding job can only be done by a certified welder. Once the welding is finished, the window repair is complete. Whenever window repairs are done, it's a good idea to hydrostatically test the boiler. Generally, a hydrostatic test should be done after fixing any failure that has caused leaks in the boiler. The repair area should be inspected during the hydro to make sure it doesn't leak. To sum up, the materials and equipment needed for a window repair are weld rod, a section of replacement tube, a grinder, a cutting wheel, a welding machine, and the usual welding tools, including a welding shield, welding gloves, and face protection. There are 5 steps in the window repair procedure. Cut out the damaged area. Cut the replacement patch to size. Prepare all the edges for welding. Tack weld the patch in place and weld the patch to the tube. That ends our demonstration of window repairs for tube failures. Now we're finished with our discussion of tube repairs in general. You should now know what causes tube failures, what these failures look like, and the 4 ways that failures can be fixed: replacing a tube section, cladding a thinned area, closing a rupture, and making a window repair. Remember, only certified welders can perform the actual welding inside a boiler. Always keep safety in mind, follow all safety precautions, and check your safety manual. Before you actually start working on the tube repairs, review the material we've covered and talk it over with your instructor.